Right, we've got a table here for the graph of y equals x squared plus x minus 4, and we're being asked to complete it. What I'd probably do is use the table function. You can substitute values in, just be careful. If you have, let's just do 1 as an example. If you have minus 4, then you need to square all of minus 4. You have to put it in a bracket because that will give you 16. So minus 4, sorry, minus 4 squared plus minus 4 minus 4. Actually, that's going to give me 8 as my answer, so I know I can put in 8 here. But let's use the table function for the rest because it's just much quicker. Go to menu, then look along for where your table function is. 3, write in f of x, alpha x squared plus alpha x minus 4 equals. Don't care about the second function. We're going to start at minus 4. We're going to end at 3. And we go up and 1 all along. So there we go. So we've got 8 as I got before, then 2, then minus 2. So I'm going to fill that one in. Then I've got minus 4. I'm going to have minus 4 again, followed by minus 2, 2, and 8. So I can see some symmetry going on, but that's all I need for the table. Now I need to draw this graph between the range that it says. So this is a case of plotting the coordinates. I know when x is minus 4, y is 8, so there's going to be a point here. When x is minus 3, y is 2. When x is minus 2, we get minus 2. Then minus 1 gives 4, minus 4. 0 gives minus 4. 1 gives minus 2. And we've got this sort of symmetry going on now. There we go. Okay, that is not the graph. That's just a bunch of points on the graph. So to get the graph, we need to join it up just in the range that it's given us. You can extend it and you'll be okay, but let's just do it between the range. Okay, just be really careful. Important to use a curved line just by hand, but that goes through all the points pretty much. Okay, that's not bad. I mean, I ended up going a bit further there. It's going to carry on going down there. That's a good graph. That's your typical quadratic graph. It's a smiley quadratic because it's an x squared. If you get a minus x squared as your leading term, then it becomes a sad quadratic. Just something to be aware of. It is symmetric. There's a line of symmetry going on, and it goes through the axes at minus 4. You can see that it's just a bit like when you have y plus mx plus c. And just going into some extra detail here. To find out where it crosses the x-axis, you would have to solve this thing equal to 0. In this case, it looks like we wouldn't get very nice numbers. We don't need to do any of that though. We've got the table, and that's enough. We've plotted the graph. But if you were sketching the graph, that's the sort of thing you'd have to do. All right. Okay, so now it's asking us, I didn't actually realize this, it's asking us to use your graph to solve x squared plus x minus 4 equals 0. So we need to read off these points here. This one here, this looks like minus, I mean, my line's quite thick, so probably anywhere between minus 2.6 and minus 2.7. There'll be some leniency given. I'm going to write minus 2.6, or x equals 1.6. Happy with that. On the same grid, draw the graph of y equals minus 2x minus 1 for the same range. You may use the table if you wish. I think I'm going to go for it. I'm just feeling confident today. So I can use y equals mx plus c, and I know that c is going to be here. Okay, it's going to be minus 1. And then I've got a gradient of minus 2. So that means for every 1 I go along, I go 2 down. But just be careful with the scale. It's a bit different. It's like 2 squares in the x direction is worth 1, whereas, sorry, when I say 2 squares, I mean like more length is needed. 2 of these kind of bigger squares is worth 1 in the x direction, whereas 1 of the bigger squares in the y direction is worth 1. So I'm going to go along 1, and then I'm going to go down 2. That's going to be a point on there. And I'm going to go along 1 and down 2, along 1, down 2. And that's, yeah, it only wanted me to go up to 3, didn't it? So that's enough. I could do the same in the other direction. I'm just going to make sure that when I fit it, it does still work. So if I go along 1, I'm going to go up 2, along 1, up 2, along 1, up 2, along 1, and up 2. And I can see that it's going to hit this bit here, and it goes through all my points. That's a well-drawn line. I could have drawn the table. When it says draw the table, I suppose it's just getting you to, it's going to be a straight line, so you actually only need, well, actually once you have 2 points, that's enough, but 3 points will just help you draw it a bit more accurately. But you could maybe try x equals 0 and y equals 0 and get those going on if you wanted. But anyway, that's what your line should look like. Use your graphs to solve the equation x squared plus x minus 4 equals minus 2x minus 1. This is where the graphs are the same because, I probably should have just labelled my graph y equals minus 2x minus 1. I'm interested in where this thing here is equal to this red thing, so it's going to be where they cross. That's going to be the solution to this equation. So it's a similar sort of thing. But note it's the x values. I'm not actually interested in the y values, so I need to read off the x values. Let's do it here. I've kind of made a big green splodge. Do you know what? I'm going to get rid of them because I think it's more confusing. So again, there'll be a range of values that's accepted. I'm reading off minus 3 points. Minus 3.7, I think. Or it's going to be this where it crosses here, and that's looking like 0.7, I'd say. But just note, your graph will look slightly different, and as long as you're pretty close to those. In a mark scheme, there will be an allowance of values allowed, given. I'm not too interested in that here. What I'm interested in is that you've got the method sorted. You know how to draw a quadratic graph. You know how to draw a y equals mx plus c kind of graph. You can read off your graph. You can draw your graphs pretty accurately, and then you understand what this sort of thing means. It means where things are intersecting, and this one here is where it intersects the x-axis. There we go.